Hi, my name is Gus and I'm going to be talking about why carbon fibre is a good material for a bike frame. It is a lightweight, high-strength material that has seen exponential growth over the past 50, 60 odd years. The carbon fibre material is combined with a matrix, commonly a thermosetting polymer, which creates the CFRP, carbon fibre reinforced polymers. Now the carbon fibre in this composite is what brings the strength and stiffness, while the matrix, the thermosetting polymer, maintains fibre alignment and transfers structural load among the fibres. Due to carbon fibre's atomic structure, it is one-directional, it is anisotropic. This means that if a force was to be applied to the carbon fibre in its original form, it would be very easy to break it, which goes against its strong characteristic. This is why it is very important for it to be woven, and very common for it to be woven in alternate directions, as seen in the figure, and this reduces that anisotropy. As you can see, a high elastic modulus and a high tensile strength is prominent with a very low density, which is why it is known to be a high strength, low weight material. There is no deformation below the tensile strength value, which means there's no yield strength, so there's no give in the material. Although this could be possibly a bad thing, because carbon fibre has such a high tensile strength and such a high elastic modulus, this means that it takes a lot of force for it to break without there being any elastic deformation. Carbon fibre has a reputation for being a very expensive material, but the carbon fibre itself is not expensive. It is the manufacturing process which is highly specialised. It is a low volume production, thousands versus millions of tonnes for aluminium and steel, and this is because it is specialised. As you can see in the figure 6, it is only produced really in first world countries. This means because it's expensive and because it's not produced locally, third world countries find it much harder to access carbon fibre. In conclusion, carbon fibre is a great high quality product. This is why it is seen in industries such as aerospace and high performance cycling. Many Tour de France riders use carbon fibre bike frames. As of right now, it is probably not the best material for a common bike frame, but maybe in the future, with cost reducing techniques put in place and improved and developed every day, this may be a good material.
Aluminium is one of the most common metals utilised around the world. It's used in planes, cutlery, cars, everything we use. It's known for the lightness, strength, and the resistance against corrosion. It has a low density, which makes it light, and it's easily machined and formed. For the criteria of the bicycle frame, it'll need to be lightweight, easily crafted, have a high relative Young's modulus value, and a resistance against corrosion for longevity of the bicycle frame. Aluminium has a density of 2.7 grams per centimeters cubed, and steel has a density of 7.84 grams per centimeters cubed, which makes aluminium 65% lighter than steel, which would be optimal for a bicycle frame. Carbon fibre has a density of 1.75 to 1.93 grams per centimeters cubed, making aluminium 54% heavier than carbon fibre. Being that it is less dense than steel, it will be less durable, but lighter, but it is also heavier than carbon fibre, but also more durable. It's easily machined due to its microstructure. It has a unique gap in the spacings of the grain boundaries, and it forms an Al3+ bond, which is low electron negativity. However, due to its properties, it is ideal for metallic bonding. Young's modulus of aluminium is between 65 to 72, which is the lowest out of steel and carbon fibre, which is its downfall. However, it does have a good resistance to corrosion. Due to being exposed to air, it creates a thin layer of oxide, protecting the rest of the metal from the rust. It's a quality not found in steel or carbon fibre. Aluminium, it is lighter than steel, but heavier than carbon fibre. It's easily manipulated due to its unique microstructure. It is uniquely resistant against corrosion, giving a relatively good longevity. However, it is the lowest Young's modulus relative to steel and carbon fibre. Aluminium is a suitable material to use as a bicycle frame, as it is a good compromise between steel and carbon fibre.
What is steel? Steel is an alloy of iron and carbon containing less than 2% carbon and 1% manganese and small amounts of silicon, phosphorus, sulfur and oxygen. Steel is the world's most important engineering and construction material. It is used in every aspect of our lives. World Steel. Steel offers advantages such as safety, speed of construction, reduced weight, and its adaptability. Steel density and strength. Steel has a density of 7.85 grams per cubic centimetres, or 7,850 kilograms per metres cubed. Civils Guide 2011. Due to the dense nature of steel, it results in less breakage and failures than other metals. Steel, whilst being strong, also remains flexible with less breakage coming as a result. Civils Guide 2021. The microstructure of steel has several benefits to its use. It pertains enhanced strength, improved wear resistance, achieved through the reduced grain size, corrosion resistance when alloyed with certain elements, and lastly, improved machinability. Steel's 190 to 215 gigapascals is quite stiff relative to aluminium, making it a more viable option as it will conserve kinetic energy. Carbon fibre has a Young's modulus of 200 to 500 gigapascals, making steel less of a viable option than carbon fibre, but still extremely practical when making a bike frame. Corrosion resistance. Steel holds a very thin oxide layer, minimising the effects of erosion. This layer keeps corrosion only localised and will often reduce the damage caused by rust, etc. The viability of steel. Steel is a dense and tough metal, improving the durability of the bike frame and reducing effects that deteriorate the material, i.e. impacts, corrosion, wear, etc. Although steel is a strong, durable and easily machined metal, it remains heavier than other materials. This is the one flaw in using steel. It is not as light as aluminium and carbon fibre.